Assalamu alaikum. Welcome to the review lecture for data mining before the midterm exam. Uh, as you already know, your midterm exam is on Friday, which is tomorrow at 6:30 p.m. So today, basically, we will briefly outline the content that we have covered in this course so far, and which would be tested in your midterm exam tomorrow. And basically, after that, if you have any questions, we can discuss those as well during this session. So we won't be covering any new content in this session. So, so we will discuss the exam as well. So I have emailed you the outline of the exam yesterday. I hope all of you have received it. Basically the exam would be around 2 hours long, and it will have about two sections. The first section would be around 13, 14 questions. These questions would be similar to the question that you saw during your quizzes, which were online. Uh, the only thing that I would say is the percentage of questions that require you to write something or calculate something would be higher. On the online exams, you typically had more questions that were MCQ type, meaning that you had to select among options. While here, you might have some question that would ask you to do a little calculation or maybe to explain briefly and so on. Of course, typically I don't ask you to write definitions and stuff like that, so that is not required. Most of the stuff would be application of what you have studied in the course. So that is part one. So around, I would say 14, 15 questions. And of course, this part one would comprise about 50% of your total marks of the exam. And part two is about three questions. These questions would be longer, and they would typically involve some data, some toy data set on which you will be applying some techniques. So the techniques that we have studied in this course from, I would say, data pre-processing to item set mining may be asked during this uh, as this part of the exam, in this part of the exam. So these questions would be longer, but as I said, there will be two to three, and again, they will form about 20-50% of your total exam marks. So you'll just have one paper, one question paper, and all answers need to be written on that question paper. Uh, and and of course, these two parts are not serial, meaning that you can start part two question at the start and do the part one later and so on. So for those who have taken, let's say, online exams last year, so those were kind of serial. Part one was one part that was done once, and then part two started. So this is just one paper, and you can do any question at any time. Uh, so I have uploaded a sample paper from a previous year. Uh, so of course, the content that was covered before the midterm of that exam might be slightly different from what was covered in the midterm. So what was covered till now in this course. So some of the questions may be beyond the content of this midterm exam. So I think all of you should be able to distinguish those questions. Uh, so the content for the course, as I said before, is up till last lecture, which was lecture 12. And I had also sent you briefly the content with respect to the books that we are using in this course. So, so any questions? Mhm. So the midterm is on Friday at 6:30 p.m. in SSE 201. All right. So please be present in the room at least 10 minutes before 6:30. Okay, so we'll discuss that. Okay. Uh, so please be available in the exam room around 6:30. Okay. So sorry, at 6:20, at least 10 minutes before the start of the exam. We will start the exam exactly at 6:30. So exam, as I said, would be around 2 hours long. So please bring a calculator and pen, and you can bring a A4 size help sheet, which could be anything that you prefer, both sides of that A4. And beyond these three main items, you cannot bring anything else. And so, so that's okay. So let me quickly go over the content, and then we can ask. No, you are not given any formula sheet. You should bring your own. So you can bring one page, A4 sized, and you can write whatever you want to write on it on both sides and bring it with you. And of course, you can even copy it if someone has made one very good, whatever you can call it, cheat sheet or formula sheet. You can copy that person's sheet as well. But it has to be just one page. I don't want it to be a long page or multiple pages. Just one page. Okay. Okay, let me quickly go over the content and we can then discuss your specific questions. So the content, of course, is introduction. We started with introduction. So introduction included, of course, the motivation for data mining, and we also defined data mining as well as part of this introduction. And then we discussed various tasks in data mining. We discussed various functionalities in data mining. We also discussed various, you can say, branches or sub uh, subfields in data mining. So all of this was part of introduction, and this is usually chapter 1 of your textbook or any textbook on data mining. So that was introduction, and then we basically talked about data understanding. So in data understanding, we started with various databases types. So you have relational databases, transactional databases. You can also have graph databases. And then we said that we primarily would focus so far on relational or tabular formats of data. And then we discussed things like attributes, types of attributes, and their characteristics. Uh, so we have various ways of categorizing attributes. So you can think of as continuous or discrete or numeric or discrete, continuous or uh, sorry. Uh, so we had the best categorization, of course, is the nominal, ordinal, and then we have interval scale and then ratio scale. So, and each has its own properties. So the whole idea was to be able to gauge the properties of an attribute based on the type of the attribute. So we then discussed things like trying to understand the data set, and we talked about central tendency and dispersion tendency. Central and dispersion tendencies. Basically, here we discuss measures, things like mean, median, standard deviation, and so on. So this could be, and data could be studied with respect to single attributes or multiple attributes, mostly at two attributes at a time during the data understanding stage. And two attributes, we typically talk about things like correlation or relationship between two attributes. So we discussed various correlation measures, chi-square, AUC, and so on, Pearson correlation coefficient. And we also discussed some basic graphs and visualizations for data. So, of course, we also discussed AUC is basically area under the ROC curve. Uh, but here we didn't go into that detail. You have a direct approach for finding AUC, area under the ROC. ROC itself is acronym Receiver Operating Characteristic Curve. So this, of course, comes from you can say statistics as well as machine learning, but here we used it to quantify the correlation between a nominal, most likely binary, and a continuous attribute, a numeric attribute. And you have a direct formula for computing it. You don't need to draw the curve and stuff like that. So we discussed that formula during the course. So that was data understanding. Uh, Anything I missed out? This is chapter 2 of your book by hand. We did not cover in detail the more complex visualizations that are part of this chapter in the textbook. So you can also skip that. We did not discuss those. So in general, what we covered in class is a good indicator of what to read from the textbook or any textbook. So if there is some stuff that is totally different from what we had covered in class, so that is not included. Okay, and then we talked about data preprocessing. So this was a relatively long chapter, and it basically was a survey of the various techniques that are available as part of data preprocessing. PCA, no. So PCA, of course, you need to know the concept what PCA is and how it is used, but you are not required to know how to compute PCA. In general, you won't be able to compute PCA without a computer. So there is no point if you think of, I cannot ask you to find PCA, the transformation matrix in the exam, but I might give you a transformation matrix and then you use it for finding the reduced data set. So that is possible. But of course, you need to know the basic concepts and operations in PCA and other techniques that we briefly talked about in data reduction. So this part of data reduction. So as I said in what is this data preprocessing? So data preprocessing. So we discussed things in various categories. We started with data cleaning. So then we talked about integration. So we talked about reduction. We then talked about discretization and so on. So within each of these categories, there were several simple to sometimes somewhat harder techniques, difficult technique. But those difficult techniques, as I said, for PCA, we did not go into the math of PCA. We just went into the concept of PCA and how it is used, not how those eigenvector matrix is computed. Okay. Of course, when we discussed data reduction, of course, is subcategorized further as feature selection and feature extraction. In feature extraction, as we said, you typically get new attributes. In feature selection, you only select from the existing attributes. So PCA is an example of feature extraction. Sometimes this is also called dimensionality reduction. This category is also called dimensionality reduction, but feature extraction is a better name. Uh, so, and then we discussed actually several ideas here. So we talked about PCA, we talked about other names as well. So this name might be quite big in other courses, but here we just want the basic idea. And non-negative matrix factorization, for example. And we also briefly discussed autoencoder. Autoencoder, of course, we will discuss in more detail later on in the course. But here I just mentioned some names. Uh, in data reduction, of course, you can have numerosity reduction as well. And we primarily discuss things like sampling and aggregation and summarization in that category. So in data transformation, so that's another category of data preprocessing. We discuss primarily normalization. And of course, most of the other things that we discuss in data preprocessing is also transformation. So we just have these various different categories just to distinguish one from the other. Uh, so so some of the things that you do for data cleaning is also transformation. PC is also transformation, for example. All right. So and then of course we had discretization, and we briefly discussed discretization techniques in general and nothing in great detail. And we briefly also introduced the idea of concept hierarchy. So this was data preprocessing and chapter 3 of the book by hand. And then we moved on to frequent pattern mining. So frequent pattern mining is chapter 6 and 7. A little bit of 7 we had covered so far. We will cover one more section after the mid of the book by hand. Plus, there is one section from the web data mining book. I have posted that chapter on LMS. So we covered the sequential pattern mining from that book. I think, if I'm not mistaken, is section 2.7 of that book. So here, of course, we started with introduction, motivation. We talked about some application like market basket analysis, web surfer mining, and web page vegetation analysis, and so on. So there are various applications. And we then discussed scalable algorithms. So we talked about a priori, and we talked about FP growth. So these are the two main algorithms that we discussed. Of course, there was a third one which we discussed as an idea, which we called the vertical format. And of course, the algorithm here, of course, there are multiple algorithms that use the vertical format. One is ECLAT, and there's another called CHARM, but we did not discuss these algorithms in detail, just the idea. Okay? FP growth and a priori we discussed in detail. Okay? So these are scalable algorithms. Of course, for a priori, we also discussed some extensions and tricks that can be used to make a priori better. For FP growth, we did not discuss such techniques or tricks, although there are also many for FP growth. So FP growth, we stuck with the basic FP growth algorithm. And then, of course, as I said, we talked about sequential pattern mining. And here we, of course, introduced the problem and the basic definition, and then we discussed the GSP algorithm, which is an extension of the a priori algorithm to sequential patterns. Okay, I will discuss that shortly. Just let me finish this. I think I'm almost towards the end. So GSP, we discussed GSP, all right? And then we talked about interestingness measures. Interestingness measures, primarily for association rules. And of course, we discussed a number of measures, and we also discussed some properties that we would like to have in these measures. And then after that, very briefly, which is chapter 7, we discussed multi-level and multi-dimensional item set mining. Here, of course, for example, we introduced the idea of predicate set, meaning that you are mining relational databases or databases that you are mining tabular format data sets, not just transactional data sets, which has attributes and values. So predicate value pairs. So that's the thing where we stopped so far. We will cover one more main section from this chapter 7, which is on constraint-based mining, and then we will move on to further topics in this course. So this essentially is the content as an overview that we had covered so far, and that would be tested in your exam. Okay, so there were a couple of questions, so let's go to those questions. So what is the vertical format? So vertical format are basically, so we had talked about transactional databases so far for item set mining. So transactional databases have transactions. So let's say A, B, C. This is the first transaction. The second transaction, let's say, is B, C, D. And let's say we have the third transaction, which is AC. So this is the standard transactional databases. And this is, of course, in the regular format. The vertical format is you flip this in a way you transpose it. The rows are now your single items and they could also be item sets. But since as I said, vertical format की डिटेल में हम बहुत ज़्यादा नहीं गए, कंसेप्ट मैंने डिस्कस किया था. So इस डेटाबेस को आपने ट्रांसपोज कर देना है. Rather than transactions being rows, we are having items as rows and columns become transactions. ठीक है, तो इस पर्टिकुलर एग्जांपल में फिर क्या होगा? So we have A as an item. अब A किस ट्रांजैक्शन में आ रहा है? 1 में आ रहा है और मे बी 3 में आ रहा है. देन वी हैव B another row. ये 1 में आ रहा है, मे बी 2 में भी आ रहा है और 3 में आ रहा है कि नहीं आ रहा? 3 में नहीं आ रहा. B C D भी है. ठीक है, ठीक है. सो वी हैव C. तो C में आपके पास ऑफ कोर्स 1 है, B C 2 भी है. दैट्स इट. And then maybe D, which is 3. So this is the vertical format of the database, and then you can do operations for finding item sets using this vertical format. So for example, if you represent uh, the transactions that contain A, so this is the set. What is the set of transactions? 1 and 3. So the size of this set is actually the count of A. So what is the size of this set? There are two transactions that contain A, 1 and 3. So the size of this set, which you can also write as 1 and 3. So 1 and then 3. So kind of the size of the set 1 and 3, which is of course equal to 2, which is the count of transaction A. So you can now do most of the operations by, or you can most of the steps in a priori algorithm, for example, by using set operations. All right. So does that answer your question? क्वेश्चन था किसी का वर्टिकल फॉर्मेट पे. अच्छा, ठीक है. अच्छा, तो और एक क्वेश्चन था शुरू में किसी ने किया था एफपी ग्रोथ पे. ठीक है. एफपी ग्रोथ में जो रिकर्शन है, द बेस्ट वे टू अंडरस्टैंड रिकर्शन इज थ्रू प्रोजेक्टेड डेटाबेसेस. सो सो लेट्स से कोई भी आपके पास कोई डेटाबेस है, ए बी सी है और ए है, लेट्स से recursion essentially means that you take bigger projected databases of that. Let's say if I take a projected database of the above, so a projected database इसका क्या होगा? मैं एक और भी डाल देता हूँ, BC भी डाल देता है, ठीक है। तो इसमें क्या होगा, ABC आएगा और AC आएगा, BC नहीं आएगा। BC क्यों नहीं आया? बिकॉज it this projected database should contain transactions that we are projecting on, which is A in this case. Of course, कंडीशनल पैटर्न बेस क्या होगा, जो हम एफपी ग्रोथ में टर्मिनोलॉजी यूज करते हैं, उसमें ए लिखेंगे नहीं हम सिर्फ बीसी लिखेंगे और सी लिखेंगे। ए हमको पता है वो फॉर श्योर होगा बिकॉज इट इज प्रोजेक्टेड डेटाबेस, ठीक है। अब लेट्स से इस डेटाबेस पे आपने फर्दर प्रोजेक्शन करनी है। सो लेट्स से इफ यू वांट टू डू ए बी प्रोजेक्टेड डीबी, ठीक है। अब सो नाउ यू आर वर्किंग ऑन दिस डेटाबेस, इसमें आप बी की प्रोजेक्शन कर रहे हैं। अब इसमें बी की प्रोजेक्शन करेंगे तो आपके पास पहली ट्रांजैक्शन सिर्फ आएगी जिसमें ए बी सी है, दूसरे में बी नहीं आ रहा, ठीक है ना। सो वी विल हैव ए बी सी। ऑफ कोर्स ये प्रोजेक्टेड डेटाबेस है। लेट्स से इसका मैं पैटर्न बेस लिखूं तो सिर्फ सी होगा, ठीक है। सो दिस इज फर्स्ट ऑफ ऑल द रिकर्शन। अब इस रिकर्शन से जो हम फ्रीक्वेंट आइटम सेट्स निकालते हैं वो इट्स बेसिकली बेस्ड ऑन काउंटिंग। अब एफपी ग्रोथ में ये डेटाबेसेस सारे कंप्रेस हो जाते हैं ट्री में, या हम ट्री में रिप्रेजेंट कर देते हैं। सो ऑल ऑफ द ऑपरेशंस आर नाउ डन ऑन द ट्री रादर देन ऑन दीज टेबल्स। बट एसेंशियली बैकएंड पे या आपकी विजुअलाइजेशन के लिए आप इसको टेबल्स ही अज्यूम कर सकते हैं। तो आपकी काउंटिंग सारी टेबल की फॉर्मेट में हो रही है, ठीक है। सो एंड सेकेंडली, सो दैट्स वन थिंग। The other thing that is important is when you are working with trees, the FP tree, frequent pattern tree, so the recursion would stop when you have number one a single path, or of course two a null tree, ठीक है। सो ऑफ कोर्स व्हेन यू हैव ए नल ट्री, इसका मतलब है आपका जो प्रोजेक्टेड डेटाबेस है वो एम्प्टी है, आप पीछे से ही आप जो ट्रांजैक्शंस जो फ्रीक्वेंट निकली तो वो पीछे ही वाली ही है। पर लेट्स से आपका एक सिंगल पाथ सिर्फ आता है, सिंगल पाथ है। लेट्स से जस्ट फॉर एक्सप्लेनेशन से, लेट्स से सिंगल पाथ ए 2 है और लेट्स से बी 1 है। सो लेट्स से दिस इज अ सिंगल पाथ दैट यू गेट, ऑफ कोर्स नल से स्टार्ट हो रहा है। So this is a single part that you get, and let's say this is the projected FP tree for, let's say ये था AB, ठीक है। A, so let's say this is a projected database for CD, let's say CD, let's say 2, ठीक है। Of course ये थोड़ा सा केयरफुल होना पड़ता है to be theoretically correct, but I'm giving a example quickly now, so I'm not reason through कि ये correct होगा कि नहीं होगा, but giving example. So let's say this is a projected database for CD2 और हमारे पास एक सिंगल पाथ है। अब इस सिंगल पाथ में जितनी भी कॉम्बिनेशंस बन रही हैं वो हम राइट अवे जनरेट कर देंगे rather than doing the recursion mining, because recursion mining करेंगे तो क्या होगा, अभी जैसे ए और बी आ रहा है, नेक्स्ट टाइम में सिर्फ ए आ जाएगा और नेक्स्ट टाइम सिर्फ बी आ जाएगा, तो वो पैटर्न वही बनेंगे। रादर देन डूइंग दैट वी डू इट एट वंस। सो क्या बनेंगे, सो इसके बेसिकली कौन से बन रहे हैं, ए बी ऑफ कोर्स वुड बी सो फ्रॉम दैट पाथ, सो ए बी आपका ऑफ कोर्स 1 है बिकॉज बी 1 है, ठीक है। और ऑफ कोर्स ए आपका वहाँ कितना है, 2 है, एंड ऑफ कोर्स बी आपका कितना है, वो 1 है। अब इन तीनों में से तीनों जो पैटर्न्स हैं इन सारों में आपने सी डी भी ऐड कर देना है। So CD, and of course you still have to worry about the minimum। CD 2 था और AB 1 था, तो इसका मतलब ये भी 1 ही रहेगा। ये 2 है, इसके साथ भी CD लगा दें, CD भी 2 था, ये भी 2 ही रहेगा। B 1 था, इसके साथ जब CD लगाएंगे तो ये भी 1 ही रहेगा बिकॉज CD ज़्यादा था, तो जो मिनिमम है वो ही रहता। तो ये पैटर्न्स आपके राइट अवे जनरेट हो जाएंगे। and you would stop the recursion and go back. And of course, if you had a null tree, तो आपके पास कोई pattern generate ही नहीं हुए, जो पीछे ही generate हुए वही थे आपके, and then you go back. So this is when you stop the recursion. You continue the recursion if you don't have these conditions, meaning that a single path and a null tree, you have a tree which has, let's say, multiple paths, then you continue doing the recursion until you reach each point, these two conditions. What else? Of course, ये मैंने generic बताया था, you have to still follow those rules of FP growth algorithm के आपने item sets, at least in the tree, you should, so at least when you create the F list, frequency descending order में आपने item sets लिखने, और tree में भी उसी order में आपने डालने, because we want compression. Uh, I'm not sure if this was clear. I also posted an example, a whole FP growth example. No, you would have to generate the FP tree. If you want to follow the FP growth algorithm in the purest sense, you have to generate the FP tree as well. Because FP growth algorithm का दो ही बेनिफिट है ना, एक जो मेन बेनिफिट ऑफ कोर्स वो कंप्रेशन वाला है, तो कंप्रेशन उस वक्त ही होगा जब एफपी ट्री बनाएंगे, अदरवाइज आप उसको एज ए डेटाबेस भी लिख सकते हैं बट उसमें कंप्रेशन नहीं होगी. सो you should in general create the FP tree unless you get a tree which is null, of course, or you get a single part tree. Of course single part tree भी है तो फिर भी tree है, जैसे मैंने ऊपर एग्जांपल लिखा था वो single part था ना, you have null and you, let's say, A2, so let's say B1, so this is still a tree. ठीक है, so tree आप in general आप बनाएंगे आप. So as I mentioned earlier, मैंने एक example post की हुई थी LMS पे, वो आप ज़रूर देखें. Plus example is also, a different example is also available in your textbook, और आपके पास कोई और textbook है तो उसमें भी होगी. And I think in the slides भी जो example थी वो भी different थी from the textbook. So आपके पास 2-3 examples तो definitely हैं. So please go over them and maybe do one of them by hand so that आपको practice हो जाए. अच्छा, तो so if you talk about complexity, I think this was the most complex. I wouldn't say it is very complex, but still, at least so far in this course, this is a algorithm that you need to at least do go over carefully and then also practice at least once. Okay, just to make sure that you don't you have understood it properly. So another thing that I would like to highlight is a priori mein jo, you have two pruning steps. So this time this concept is not often made clear in the textbooks. I made this clear in the lectures, but I'm repeating it here, that there are two pruning steps. So one is before counting, and then of course after counting. So what is before counting? You have generated the candidates, but before you even scan the database and count those candidates, you check whether those generated candidates are really or those generated candidates do not, or whether those generated candidates are possible or not, meaning that they should have all their subsets, their k minus 1 subsets in the frequent k minus 1 item sets. So आप उसके सारे k-1 सबसेट जनरेट करें और देखें कि वो Lk-1 में अवेलेबल हैं कि नहीं है. If any one of those subsets is not available in Lk-1, you delete this candidate even before scanning the database. So this is before counting. And then whatever is left, then you scan the database and count them. And maybe even after counting, you might find some candidates that are not frequent. You delete them at that point. Okay. We also, of course, discussed the notion of closed item sets and max patterns, closed and max patterns. Of course, in the textbooks, you will find, I think, a section in which some algorithms are discussed for finding closed and max patterns directly. So, वो algorithms we had not discussed in this course, but we have discussed the concept of max and closed patterns. So, if I give you some frequent item sets, you should be able to manually figure out which are the closed item sets and which are the max item sets. Okay. Yes, that's true. So if you don't delete before, but if you don't delete before counting, it will delete after counting. That's for sure. But obviously, you would like to reduce the overhead of counting. So if you prune before counting, so uh, you would not check for that item set when you are counting. So that is reducing the overhead. So usually you should do the two-step pruning in practice.
सर
जी.
सर कैंडिडेट्स हम सारे पॉसिबल कैंडिडेट्स जितने बन सकते हैं प्रीवियस फ्रीक्वेंट सर्च में से वो बनाते हैं या फिर जो जिस तरह अगर हमारे पास टू फ्रीक्वेंट सर्च है ए बी सी एंड ए बी डी अब ए बी इनमें कॉमन है ए बी सी डी नेक्स्ट कैंडिडेट सेट बन सकता है एंड लेट्स
जी जी.
जस्ट से कि नेक्स्ट थर्ड कोई फ्रीक्वेंट सेट हो बी सी डी अब इसके साथ कॉमन किसी का नहीं है तो ये हम कैंडिडेट सेट नहीं लेते तो कैंडिडेट सेट फॉर नेक्स्ट एल जो भी है इज ए बी सी डी तो इसमें फिर फर्स्ट स्टेप ऑफ प्रूनिंग की जरूरत तो नहीं पड़ेगी क्योंकि इसका हर सबसेट तो ऑलरेडी एग्जिस्ट करते हैं प्रीवियस फ्रीक्वेंट सेट में
दो सबसेट्स तो हमेशा होंगे. देखा ना, जिन दो सबसेट से आपने जनरेट किया. सो लेट्स से आपने एग्जांपल दी ए बी सी की और ए बी डी की. तो इससे जब आप जनरेट करेंगे तो आपके पास ए बी सी डी आएगा. ठीक है ना. इसमें इसके जो थ्री सबसेट्स हैं वो ए बी सी है और ए बी डी है. वो दोनों थे बिकॉज इन्हीं से आपने जनरेट किया. बट इसमें से एक और सबसेट भी है, वो बी सी डी है. इफ इट वॉज प्रेजेंट इन द प्रीवियस लिस्ट तो वो ये डिलीट नहीं होगा बिफोर काउंटिंग. बट हेयर इन दिस केस सिंस इट इज नॉट प्रेजेंट वी विल डिलीट इट बिकॉज इसका एक सबसेट है विच इज नॉट फ्रीक्वेंट.
ओके सर
तो यही पूछ रही थी ना आप. आई एम नॉट
यस सर
100% श्योर. हाँ जी,
सर
ठीक है.
अगर थर्ड वाला बी सी डी होता
हाँ,
प्रीवियस
बी सी
फ्रीक्वेंट
डी
सेट
होता
में
तो फिर ये डिलीट
देन
नहीं
ना
होता.
डिलीट होता है
जी
ठीक
जी.
है
ऑफ कोर्स इसमें आपका एक कई लोग के क्वेश्चन पूछते हैं, हमें पिछले कोर्सों में भी लोग मुझसे पूछते हैं कि समटाइम्स हमने सिर्फ दो यूज करके जनरेट किया ना, तो हम किसी और तरीकों से भी जनरेट कर सकते हैं. सो दैट इज ओनली मेंट फॉर बुक कीपिंग. सो हम और ए प्रायरी एल्गोरिथम में एक बुक कीपिंग की है विच इज लेक्सिकोग्राफिक ऑर्डरिंग को लेके पहले इन दिस केस पहले दो आइटम्स को कॉमन रख के तीसरा आइटम दूसरे आइटम सेट का चौथा आइटम ऐड कर दें. सो दे माइट बी अदर वेज ऑफ डूइंग दिस. ठीक है ना. बट इन ऑल केसेस जब आप दो आइटम से एक हायर ऑर्डर आइटम सेट बनाते हैं उसके कुछ लोअर सबसेट्स भी होते हैं जो उसको जनरेट कर सकते हैं. वो हमने चेक करने हैं कि वो अवेलेबल हैं कि नहीं है. तो वो नहीं है तो इसका मतलब है कि ये जनरेट नहीं होना चाहिए था. तो वो बिफोर काउंटिंग वाला प्रूनिंग है. And the same idea applies to the GSP algorithm as well. तो जीएसपी एल्गोरिथम में भी एक सिस्टमेटिक तरीका है दो सीक्वेंसेस से एक हायर ऑर्डर सीक्वेंस जनरेट करना, बट उन्हीं दो सीक्वेंस से वो हायर ऑर्डर सीक्वेंस जनरेट हुआ है, मे बी दे माइट बी अदर सब सीक्वेंसेस दैट कुड हैव जनरेटेड दैट, सो वी जस्ट नीड टू चेक कि वो उसका सब सीक्वेंस पिछले में है कि नहीं है तो वो भी डिलीट हो जाएगा. So GSP, as I said, is identical to a priori. The only difference is, of course, we are dealing with sequences, and for sequences, we have a slightly different notion of subsequence and supersequence. अच्छा, तो anything else? Anything else? Yes, that's important. But, uh, I didn't understand the second problem, but yes, it's required to use some fixed order. So even if you don't have an order in your data set, you define one order and stick with it. And this is only meant to ensure that you don't do duplicate work, you don't do redundant work. ठीक है ना? Otherwise, you will be generating, for example, so for example, if you do not write ABC in this particular way, you could also have written BAC, even though this is a set. ठीक है ना? So A, C, B भी आप लिख सकते थे. So, and oftentimes you wouldn't have one way of generating this. You might have multiple way of generating them. So you will be doing redundant work that is in a way just adding to your overhead and nothing else. So we define some order and you stick with it. And the term that is often used is lexicographic order, some lexicon, and you follow that lexicon. Of course, if it is alphabets like ABC, you know that lexicon is the English alphabet, so you follow ABC order. But if it is something else, let's say, okay, okay, I'll come to that. All right. Okay, so what was I talking about right now? Okay. So, okay, I was talking about lexicographic. So you just define a fixed order and then you follow that. So maybe your items may don't have any natural order. You just define some order. So let's say आपके पास I don't know कुछ items हैं store में, तो you can define any order, but you stick with it. So for example, आपके पास for example shirt है, shirt को आपने कोड 1 दे दिया, और लेट्स से आपके पास जीन्स हैं उसको कोड 2 दे दिया, एंड देन यू जस्ट फॉलो दैट ऑर्डर. ठीक है. Okay, we had a question on partitioned a priori and DIC. So partitioned a priori basically is an algorithm that partitions the transactional database, and okay, so let's say you have a transactional database D, right? So you can partition D into any number of smaller data sets such that when all those data sets are added together, you get the full data set, right? So the whole idea is that we would like to divide it into smaller chunks such that each chunk fits into memory. And you can do that. For example, let's say a data set is 100,000 transactions. And let's say you know that in your memory, only 1,000 transaction would fit in. ठीक है ना? So what you do is you make 1,000 partitions. तो जब भी आप एक पार्टीशन रीड करेंगे विच इज़ 1000 आइटम सेट्स, उसके ऊपर सारी आप प्रोसेसिंग कर लेंगे इन मेमोरी. सो डेटाबेस स्कैन नहीं होगा, ऑफकोर्स डेटाबेस स्कैन होगा बट वो इन मेमोरी होगा, नॉट फ्रॉम द एक्सटर्नल data, external hard disk. And of course, internal scanning and memory scanning is much faster. So that's one idea. The other idea is, of course, you find all frequent patterns in each partition separately using the same minimum support, not support count, but minimum support as a fraction or a percentage. So min support. Okay? So if your data set is 1000, तो उस पे let's say minimum support 0.1 है as a fraction, तो 1000 के लिए आपको 10 transactions चाहिए, and 100,000 में of course आपको 1000 transactions चाहिए होंगे. ठीक है. So you find all frequent item sets in each transaction, each database. So let's say FIDI is a set of frequent item sets in each partition. Okay? And as I said, you can do this by scanning that partition once from outside hard disk into memory. Okay? So you have found all these frequent item sets. But then you have multiple partitions, right? So what you do is you have you generate a candidate for the entire data set D, which is basically uh, union actually union of all those i's. Okay? So you might have, let's say A B आपको first partition में मिला और A B आपको 10 में भी मिला, आपको A B 100 में भी मिला, तो you'll just keep A B. So that would be a candidate for the entire database. Of course, if AB occurs in all those partitions, then for sure it is frequent. But if it is missed in even one of those partitions, then it's a candidate. You still need to scan the whole database to find out its exact count. Okay? So that's basically the main two or three things that you need to know about the partitioned a priori. Okay? The first thing is, of course, you partition such that each partition fits into memory. Second thing is you find all frequent item sets in each partition. Thirdly, you create a candidate set for the entire database by taking the union of the frequent item sets in each of those partitions. And then finally, you scan the whole database one more time, and from the CD, you get the FD, the final. So from that, you basically do another scan and find FD. Okay? So essentially just two scans of the whole database. The first scan for each of those partitions, and the second to count the final count of the item sets in the candidate item sets list. So the other was the dynamic item set counting approach, DIC. This is the whole algorithm is a bit more complicated, but we discussed the simple idea in this course that essentially it is keeping track of which transaction in the transaction database contains frequent item sets. If at any given point in time of your a priori algorithm, a particular transaction, let's say we are talking about transaction 320, if transaction 320 does not contain any frequent item set in L kth step, so what we do not scan 320 for L k plus 1 and higher. So that's the idea behind DIC. Because if no frequent item set in LK was found in this transaction, then obviously any super item set would also not be found in that. So we don't need to scan it. तो एक किस्म का एक फ्लैग उस ट्रांजैक्शन के आगे हम ऑन कर देते हैं, नेक्स्ट टाइम वी स्किप इट. Okay. Any other question? अच्छा, ठीक है. तो so I'll just wait a couple of more minutes. If there are no questions, we can then end the session.